Hey guys, so today we're going to solve some more systems of equations, but this time we're going to use a new method because it doesn't seem like anybody really liked substitution so much. So hey, I'm going to show you how to use elimination today. We're looking to decide when should you use elimination instead of graphing or substitution or any of the other methods, and how exactly do you use elimination to solve the system. So eliminate just means to get rid of or remove, and that's all we're going to do in this case. We want to get rid of one of the variables in the system so that I only have one left to solve for. That makes it a whole lot easier, right? Take a look at that first example right there. In this case, we're going to be eliminating by adding our equations together. Pretty simple, right? Watch this. If I add these equations straight down, I need to make sure that my x's and y's are all lined up. Everything needs to be in order because otherwise I can't do any adding. I'm good to go because 3x's over the x, my 5y's are lined up, and my constants over here are one on top of the other. So I'm ready to add straight down. 3x plus 1x is 4x. And here's the cool part. What's 5y minus 5y? Well, it's nothing, right? The y terms just went away. I eliminated the y variable right there. Over here, 10 minus 10 is 0. And now I'm just left with one variable, x. That's really easy to solve for. There's a 4 stuck on that x, so I'm going to divide the 4 off, and I'll be left with x equals 0. Remember, that's only half your answer. Once you have half the answer, take it back to one of the original equations and plug it in to find the other one. In this case, it doesn't matter which one you plug it into, the first one or the second one. I say choose the one that's easiest. It's kind of a toss-up here, so I'm going to recommend we plug back into the first one because there's no negatives. So I take out the x and put the 0 in its place since now I know the value, and finish writing my equation. Now I just solve for y because, again, I only have one variable left to deal with. 0 plus 5y. The 0 doesn't mean anything, right? So I can simply divide that 5 off, and I'll be left with y equals 2. Now I have a whole answer. 0, 2 is my final solution. Since there's only one solution, I can say that it's independent. And that's pretty much all there is to it. Let's try another one. So I have a system. First I want to verify that my variables are stacked. X's are on top of each other, the y's are stacked, and then the constants are stacked. So I'm ready to solve. This time I look and I think, well, what's going on here? Negative 2x plus 3x will leave me with a 1x, so that's not going to eliminate. And look at these y's. 1y plus 1y leaves me with 2y. Well, that didn't go away either. So I'm going to have to tweak this one just a little bit before I can go through and actually eliminate. I need for a variable to go away, and things go away when we do the opposite to them. So it makes sense that if I could make this y right here a negative, or make this y a negative, that then they would eliminate. It doesn't matter which one you pick. I'm going to just pick this one. Remember that number 1 rule of algebra. If you do it to one, do it to everything. So I'm going to change everybody by making it negative. All right? So if I distribute this negative through to all 3 pieces, change everybody, I have a new equation. So everybody see how that changed? Multiplying by a negative just changes everybody's signs. Then bring this first equation right here back down and let's stack it underneath. Now I'm ready to eliminate because look at those y's. They're exact opposites, so I know they're going to cancel out once I add them up. Negative 3x plus a negative 2x is a negative 5x. Negative y plus y eliminates, and 2 plus 8 will leave me with 10 over here. If I divide by that negative 5, I'll be left with x equals negative 2. Again, that's half my answer. So I need to bring that back up to the top and plug it in either equation and then solve some more. This time I'm going to choose the second equation. So 3 times a negative 2 plus y equals negative 2. And now we just do the math. Y is almost by itself, so I'll bring the 6 over, and y equals 4. So my final solution is negative 2, 4. And since there's only one, it's an independent solution. All right, next example. Oops. Next example is right there. Step number 1, verify that your variables are stacked. This time I have a y sitting on top of an x. Well, that doesn't work so well, so let's rearrange this a little bit. I'm going to take this top equation and I'm going to rearrange it underneath the second equation because this one's already real pretty. See how it's an x and a y equals a number? Remember, all we're doing is rearranging. I'm going to flip this whole equation around. Make sure that you're doing it legally though, right? Let's come over here and do it legally. 8y equals all this. And I know that I need that 10x to be over on the other side, so it'll be x, y equals a number. Well, that's no big deal. We'll just do the opposite to it and bring it over. So now I have 10x plus the 8y equals 12. See how I did that? I just rearranged it to make it work better for me. Now I'm going to bring the second equation and stack it underneath. And now I'm ready to add because look what's going to happen to those 10x's. They're already opposites for me, so I don't have to do any more tweaking. The 10x's eliminate. And here I'm left with a negative 7y and 7 right there. Divide that negative 7 off, and y equals negative 1. Again, that's half your answer, so jump back up and plug it in and solve for x. Does everybody see how I just plugged the negative 1 in for y in that first equation? 8y is now 8 times negative 1. And now I'm just going to simplify and solve by moving the 12. If I divide that negative 10 off, x will equal positive 2. The final answer then is 2, negative 1. And again, since there's exactly one solution, it's independent. So for the next couple of examples, I'm going to, I was going to tell you I was going to turn this off so you didn't have to listen to me. But guess what? We just hit one of the special cases. So I'm going to leave it on and talk to you anyway. Aren't you excited? Watch this. Looking at my equations, everything's stacked. Looks pretty nice and pretty. I notice that nothing's going to cancel though. To get the 9 y's to cancel, I'm going to have to make one of them positive and one of them a negative. Well, I can do that by multiplying this guy by negative 1. If I distribute that through to everybody, then I'll end up with a new equation. I'm going to write it under here. Now I see that something's going to cancel. In fact, too much stuff is going to cancel. This is one of those special situations we discussed the other day when we were doing substitution, when everything goes away and you're left with no variable to solve for. Because watch, 24x minus 24x, 9y and a negative 9y. That leaves me with nothing on the left-hand side. That's 0, because something minus itself is 0. On the right-hand side, I have a negative 2 left over. There's nothing more I can do here because there's simply no math left to take care of. There's no variables to solve for. There's nothing else to do. At this point, you have to recognize that this is a special case. This is either where your lines are parallel or where they're the same line graphed right on top of each other. And there's infinite solutions, one or the other. The way you decide is to take whatever's left over when you get to the end and evaluate it for truth. Does 0 equal a -2? Are they equivalent? Are they the exact same number? The answer is no, they're not the same. That is not a true statement. That means that you have the parallel situation. So there are no answers. This is an empty set. If it's an empty set and there's no answers, then it's inconsistent. Just for kicks, if you had evaluated this yellow statement over here and it had been true, that would have been the other situation right here, where you had infinite solutions. I think I put one like that on here in just a minute. Let's jump down here. Alrighty, got another situation where they're not properly stacked for me. I have an x over a number, so let's rearrange. In this case, I don't have to do anything but flip-flop the whole second equation over. So let's rewrite the first one. And look, if I rewrite this one, all the x's and y's are already on the same side, so let's just put them in the right place. Now you can probably already tell what the answer is just by noticing that the fact that we have two exact same equations. But we're going to go ahead and do the math anyway, just so you can see in case it happens differently next time. My 7x's are not going to cancel, neither are my 4y's, because I need somebody to be a negative. So let's multiply one equation by a -1 so that all the signs will change. Now let's bring this guy and stack it underneath. And now add your equations together. The 7x's go to 0. The 4y's eliminate and go to 0, so I'm left with nothing. And look what happens over here. A -3 eliminates a +3. Those are opposites, so I end up with another situation where there's no variables to solve for. It's another special situation like this, or one where it's graphed twice on top of itself. So remember what I told you in the last example. Evaluate the final statement for truth. Does 0 equal 0? Are they the exact same number? This time the answer is yes. So it's going to be this situation. Two lines that are exactly the same and they graph on top of each other, so they touch an infinite number of times. So the number is, or excuse me, the answers are infinite solutions, making it a dependent answer. Alrighty, one more example. I'm going to pause it here, save you a little time and a little bit of yapping, and I'll work it and come back in just a second. Alrighty, so I worked this one all out by multiplying that second equation by a -1, because nothing was going to cancel just in the original problem. Ended up with y equals 1, and I brought it back up and plugged it into the first equation. Even though it didn't matter, I could have plugged it into this one. When I did that, I worked it all out and ended up with x equals 5/2. No big deal though, we're not afraid of fractions. If you're concerned when you get a fraction or a decimal answer, remember you can just plug your x and y back into both equations, and if you get 10 and -2, then you know you did a great job. In fact, I was concerned and I checked it myself just to make sure I wasn't lying to you about the answer. And it works, it really is 5/2. Last two, keep hanging in there with me. This time we got a word problem. Please remember that when you get this, these kind of problems where you have to write your own equations, just write what you read, alrighty? Each sentence is 99% of the time its own separate equation. So in this case, it tells me the sum. That tells me I need a plus sign. And the sum of two numbers, well, if I keep reading, I recognize that it doesn't tell me what the two numbers are. So I call those x and y. So this x plus y represents the sum of two numbers, the first part of my sentence. Is the equal sign, and 26 is just the number 26. Ooh, look right here. Their difference is 20. They didn't give us two separate sentences this time. They got sneaky and combined it into one. But that's no big deal. There is just referring to the numbers. Because if you read the whole thing, think about it. The sum of two numbers is 26, and their difference is 20. Well, difference is subtraction. Is the equal sign. 20 is a 20. This is one of the most simple problems, honestly, that you ever will have to write equations from. But to be real blatantly honest here, it throws my students for some reason. Year after year after year, you guys really try to make this one harder than it is. So trust me, when all you got to do is add the two numbers and then subtract the two numbers. Now it's just a system that we can solve quickly with elimination. Because look at those y's. They're already opposites. So I'm left with 2x and 46. It's easy to solve by dividing by 2. So x equals 23. Same as before, take it back and plug it into one of the original equations, and then find your other value. And there's your answer. You can check it by checking the original problem statement and just see, does it make sense? The sum of two numbers is 26. Well, 23 plus 3 is 26. That works. Their difference is 20. So 23 minus 3 really is 20. That means I've found my two numbers, so I'm good to go. Down here we've got another one of those where this was like we talked about on the test the other day, where lollipops plus lollipops has got to give you lollipops in the end, right? Well, here it says we've got 4 pairs of athletic shoes, which is X, and is your plus sign. 6 pairs of shorts, Y. I think I may have just misspoken. I don't know. 4 pairs of athletic shoes and 6 pairs of athletic shorts is, right there, was my equal sign. And then the total is 144.60. The second sentence is your second equation. Cost of 4 athletic shoes, so that's 4x, and 4 shorts is 129.60. Straight translation. This is a lot like what we did with substitution, except look at the way the equations are arranged now. This one is going to be better to use elimination because it's already set up for that. Substitution would be a real pain in the rear trying to solve this system. If I'm going to solve it, I look at my x's, and I notice that they're not going to eliminate. Check out my y's. They're not going to eliminate. So let's multiply somebody by a -1. Whoops. So this red equation has now been transformed to the blue one. Let's bring this guy down. Now I'm set for elimination. -4x and a +4x eliminate, and I'm left with this. Oh, hold on, I have to do the math on my calculator there. Got a decimal. So we're going to keep our fingers crossed that this is right. We'll check it in just a minute to make sure. Divide it by 2. I'm going to leave that as 15 halves. But you could change it over to 7.5 if you wanted. In fact, that's kind of a pretty decimal. That might be a better option when we're plugging this back in. Let's try the 7.5 and see if it works. There's my y value, or shorts in this case, right? Let's come back up here and plug it in right there. See what we get. So it's the first equation, and I simply took out the y and plugged in the 7.5 in its place. Bring this 45 to the other side. Last, I can divide off that 4, and I'm left with $24.90. your final answers, make sure that you're actually giving me dollars there and not just random 24.9. Because since the problem asks how much do they cost, it makes sense that my answer would be in dollars. X is 24.90, but remember that is shoes we're referring to here. Okay, now I'm going to pause it one more time, check my answer just to make sure I did this. Good news, I did it right. That's all there is to it. The trick is just make sure that your variables are stacked, then make sure that before you start adding, something is going to eliminate. If not, tweak something until it does eliminate. Now lastly, I have to add this little piece in because I missed it on the video number 22 or 23, whatever you want to call it. The other day was the illustrious Jackson Hamilton's birthday, and I promised him that I would give him a video shout out, and I totally forgot because I've lost my mind. You know how that goes. So, Mr. Jackson Hamilton, this is for you. This is your birthday song. It isn't very long. Hey! Hope you had a great birthday. See you guys later.